Hello, good evening. Welcome to our channel. Today we want to handle the reduction formula. So we can derive a reduction formula for any function. And so today we have the reduction formula for sine. We have sine power n x dx. We want to derive a reduction formula. We are going to let I n to be the integral of sine nx dx. But now you can see we only have one function, which is sine power nx. But now the reduction formula works by using the integration by parts. You can see the video attached in the description box. Now we need to separate this function into two. We are going to have sine to power n minus 1x times sine x dx. So we have two functions which, if we contract them, we get back to one function. And now we have our I subscript n to be sine x to power n. By integration by parts, our u will be sine power n minus 1x. When we differentiate, we're going to differentiate using chain rule. We will have n minus 1 sine n minus 2 of x times cos x, and now then we have dx. Our dv is going to be sine to power n x dx. If we want to get our v, we will have to integrate. And now, this is not to power n, rather it's just sine x. This one is sine x dx. So our v, if we integrate, we are going to get cos x. So we are very free to apply our formula. So we are going to have uv and our uv. So in, when we integrate, will give us uv. Uv is minus sine n minus 1x cos x minus v du. But our v has a negative, we have a negative on the other side, so it's going to be a plus. Our du has a constant n minus 1. We're going to factor out that constant. We're going to get n minus 1 cos x sine n minus 2x cos x dx. But now see here, we have cos x, meaning we can actually shrink everything together, is equals to minus sine n minus 1 x cos x plus n minus 1. We said it's our constant. Integral of, we are going to cos x. Now that gives us cos squared x sine n minus, not 1 really, minus 2x dx. But now you can see here we have sine and sine, so we're going to change this cos squared x. We're going to use the quadratic identity. Cos squared x plus sine squared x is equals to 1. Doing that, we will get sine n minus 1x cos x plus n minus 1 into brackets. Let's write this properly. The integral of 1 minus sine squared x. We have sine n minus 2x dx. So we are going to continue in the same manner. But now again, see, we have sine squared 1 minus sine squared x, and then we have sine x n minus 2. We can actually expand that. we continue. I power n is equals to minus sine n minus 1x cos x plus n minus 1 in brackets sine x n minus 2 dx. We're expanding the brackets up here, minus sine n power x dx. But now don't forget that all of these are affected by n minus 1. And then remember that I to power n, we have said, is equals to the integral of sine nx dx. It's the same as here. The only difference is that our n here is I n minus 2, and on the other side we have I n. And now we see that we can actually substitute, and now when we substitute, we are going to have I power n is equals to minus sine n minus 1x cos x plus n minus 1 into brackets. We are going to have I n minus 2 minus I n. So in that manner, we are going to expand because we want to get the reduction formula actually. So I power n is equals to minus sine n minus 1x cos x plus, we're expanding the brackets, we're going to have n minus 1 I n minus 2 minus n minus 1. So we're going to expand the brackets here, n minus 1. So we're expanding, we're going to have n I n plus I power n. You can see we have I n, so we will subtract with I n, and then n I will go to the other side. So we are going to collect the like terms. We will have I n subscript n is equals to minus sine n minus 1x cos x plus n minus 1 into brackets I n minus 2. We are only interested in the I n, so we are going to divide here by n and divide here by n. And now finally we are going to have our formula as I n is equals to minus sine n minus 1 cos x over n plus n minus 1 over n I n minus 2. You can as well decide to replace the I n minus 2. You will have something like minus sine x. We have an x here, but it's to power n minus 1. So let's just delete that and get it the correct way. So we are going to delete here. Let's just we're going to have minus sine n minus 1x cos x over n plus n minus 1 over n. We can replace here. We are going to have our I to power n, also this one we will have sine. So let's just delete here manually. Sine n minus 2 of x dx. Thank you.